El Niño.
El Niño is a band of anomalously warm ocean water temperatures that periodically develops off the Pacific coast of South America. Extreme climate change pattern oscillations fluctuate weather across the Pacific Ocean, which results in fluctuating droughts, floods, and crop yields in varying regions of the world. There is a phase of El Niño Southern Oscillation, ENSO, which refers to variations in the temperature of the surface of the tropical eastern Pacific Ocean, El Niño and La Niña, and in air surface pressure in the tropical western Pacific. The two variations are coupled. The warm oceanic phase, El Niño, accompanies high air surface pressure in the western Pacific, while the cold phase, La Niña, accompanies lower surface pressure in the western Pacific. Mechanisms that cause the oscillation remain under study. Developing countries dependent upon agriculture and fishing, particularly those bordering the Pacific Ocean, are the most affected. El Niño is Spanish for the boy, and the capitalized term El Niño refers to the Christ child, Jesus, because periodic warming in the Pacific near South America is usually noticed around Christmas.
Definition.
El Niño is defined by prolonged warming in the Pacific Ocean sea surface temperatures when compared with the average value. The accepted definition is a warming of at least 0.5 DEGC, 0.9 DEGF, averaged over the east central tropical Pacific Ocean. Typically, this anomaly happens at irregular intervals of 2 to 7 years, and lasts 9 months to 2 years. The average period length is 5 years. When this warming occurs for only 7 to 9 months, it is classified as El Niño conditions. When it occurs for more than that period, it is classified as El Niño episodes. Similarly, La Niña conditions and episodes are defined for cooling. The first signs of an El Niño are rise in surface pressure over the Indian Ocean, Indonesia, and Australia, fall in air pressure over Tahiti and the rest of the Central and Eastern Pacific Ocean, trade winds in the South Pacific weaken or head east, warm air rises near Peru, causing rain in the northern Peruvian deserts, warm water spreads from the West Pacific and the Indian Ocean to the East Pacific. It takes the rain with it, causing extensive drought in the western Pacific and rainfall in the normally dry eastern Pacific. El Niño's warm rush of nutrient-poor water heated by its eastward passage in the equatorial current, replaces the cold, nutrient-rich surface water of the Humboldt Current. When El Niño conditions last for many months, extensive ocean warming and the reduction in easterly trade winds limits upwelling of cold nutrient-rich deep water, and its economic impact to local fishing for an international market can be serious.
Southern Oscillation.
The Southern Oscillation is the atmospheric component of El Niño. This component is an oscillation in surface air pressure between the tropical eastern and the western Pacific Ocean waters. The strength of the Southern Oscillation is measured by the Southern Oscillation Index, SOI. The SOI is computed from fluctuations in the surface air pressure difference between Tahiti and Darwin, Australia. El Niño episodes are associated with negative values of the SOI, meaning there is below normal pressure over Tahiti and above normal pressure of Darwin. Low atmospheric pressure tends to occur over warm water and high pressure occurs over cold water, in part because of deep convection over the warm water. El Niño episodes are defined as sustained warming of the central and eastern tropical Pacific Ocean. This results in a decrease in the strength of the Pacific trade winds, and a reduction in rainfall over eastern and northern Australia.
Walker circulation.
During non-El Niño conditions, the Walker circulation is seen at the surface as easterly trade winds that move water and air warmed by the sun toward the west. This also creates ocean upwelling off the coasts of Peru and Ecuador and brings nutrient-rich cold water to the surface, increasing fishing stocks. The western side of the equatorial Pacific is characterized by warm, wet, low-pressure weather as the collected moisture is dumped in the form of typhoons and thunderstorms. The ocean is some 60 centimeters, 24 in, higher in the western Pacific as the result of this motion.
Effects of ENSO warm phase El Niño. South America.
Because El Niño's warm pool feeds thunderstorms above, it creates increased rainfall across the east central and eastern Pacific Ocean, including several portions of the South American west coast. The effects of El Niño in South America are direct and stronger than in North America. An El Niño is associated with warm and very wet weather months in April-October along the coasts of northern Peru and Ecuador, causing major flooding whenever the event is strong or extreme. The effects during the months of February, March, and April may become critical. Along the west coast of South America, El Niño reduces the upwelling of cold, nutrient-rich water that sustains large fish populations, which in turn sustain abundant seabirds, whose droppings support the fertilizer industry. The reduction in upwelling leads to fish kills off the shore of Peru. The local fishing industry along the affected coastline can suffer during long-lasting El Niño events. The world's largest fishery collapsed due to overfishing during the 1972 El Niño Peruvian anchoveta reduction. During the 1982-83 event, jack mackerel and anchoveta populations were reduced, scallops increased in warmer water, but hake followed cooler water down the continental slope, while shrimp and sardines moved southward, so some catches decreased while others increased. Horse mackerel have increased in the region during warm events. Shifting locations and types of fish due to changing conditions provide challenges for fishing industries. Peruvian sardines have moved during El Niño events to Chilean areas. Other conditions provide further complications, such as the government of Chile in 1991 creating restrictions on the fishing areas for self-employed fishermen and industrial fleets. The ENSO variability may contribute to the great success of small, fast-growing species along the Peruvian coast, as periods of low population removes predators in the area. Similar effects benefit migratory birds that travel each spring from predator-rich tropical areas to distant winter-stressed nesting areas. Southern Brazil and northern Argentina also experience wetter than normal conditions, but mainly during the spring and early summer. Central Chile receives a mild winter with large rainfall, and the Peruvian-Bolivian Altiplano is sometimes exposed to unusual winter snowfall events. Drier and hotter weather occurs in parts of the Amazon River Basin, Colombia, and Central America.
North America.
Winters, during the El Niño effect, are warmer and drier than average in the northwest, northern Midwest, and northern Mideast United States, so those regions experience reduced snowfalls. Meanwhile, significantly wetter winters are present in northwest Mexico and the southwest United States, including central and southern California, while both cooler and wetter than average winters in northeast Mexico and the southeast United States, including the Tidewater region of Virginia, occurred during the El Niño phase of the oscillation. Some believe the ice storm in January 1998, which devastated parts of southern Ontario and southern Quebec, was caused or accentuated by El Niño's warming effects. El Niño warmed Vancouver for the 2010 Winter Olympics, such that the area experienced a subtropical-like winter during the Games. El Niño is credited with suppressing hurricanes, and made the 2009 hurricane season the least active in 12 years.
Tropical cyclones.
Most tropical cyclones form on the side of the subtropical ridge closer to the equator, then move polluted past the ridge axis before recurving into the main belt of the westerlies. When the subtropical ridge position shifts due to El Niño, so will the preferred tropical cyclone tracks. Areas west of Japan and Korea tend to experience much fewer September-November tropical cyclone impacts during El Niño and neutral years. During El Niño years, the break in the subtropical ridge tends to lie near 130 DEGE, which would favor the Japanese archipelago. During El Niño years, Guam's chance of a tropical cyclone impact is one-third of the long-term average. The tropical Atlantic Ocean experiences depressed activity due to increased vertical wind shear across the region during El Niño years. On the flip side, however, the tropical Pacific Ocean east of the dateline has above-normal activity during El Niño years due to water temperatures well above average and decreased wind shear. Most of the recorded East Pacific Category 5 hurricanes occurred during El Niño years in clusters.
Elsewhere.
In Africa, East Africa, including Kenya, Tanzania, and the White Nile Basin, experiences, in the long rains from March to May, wetter than normal conditions. Conditions are also drier than normal from December to February in South-Central Africa, mainly in Zambia, Zimbabwe, Mozambique, and Botswana. Direct effects of El Niño resulting in drier conditions occur in parts of Southeast Asia and northern Australia, increasing bushfires, worsening haze, and decreasing air quality dramatically. Drier than normal conditions are also in general observed in Queensland, inland Victoria, inland New South Wales, and eastern Tasmania from June to August. Many ENSO linkages exist in the high southern latitudes around Antarctica. Specifically, El Niño conditions result in high-pressure anomalies over the Amundsen and Bellingshausen seas, causing reduced sea ice and increased polluted heat fluxes in these sectors, as well as the Ross Sea. The Weddell Sea, conversely, tends to become colder with more sea ice during El Niño. The exact opposite heating and atmospheric pressure anomalies occurred during La Niña. This pattern of variability is known as the Antarctic dipole mode, although the Antarctic response to ENSO forcing is not ubiquitous. El Niño's effects on Europe appear to be strongest in winter. Recent evidence indicates that El Niño causes a colder, drier winter in northern Europe and a milder, wetter winter in southern Europe. The El Niño winter of 2009-10 was extremely cold in northern Europe, but El Niño is not the only factor at play in European winter weather, and the weak El Niño winter of 2006-2007 was unusually mild in Europe, and the Alps recorded very little snow coverage that season. In more recent times, Singapore experienced the driest February in 2010 since records began in 1869, with only 6.3 mm of rain falling in the month and temperatures hitting as high as 35 DEGC on February 26. The years 1968 and 2005 had the next driest Februaries, when 8.4 mm of rain fell.
Effects of ENSO's cold phase La Niña.
La Niña is the name for the cold phase of ENSO, during which the cold pool in the eastern Pacific intensifies and the trade winds strengthen. The name La Niña originates from Spanish, meaning the girl, analogous to El Niño meaning the boy. It has also in the past been called Anti-El Niño, and El Viejo, meaning the old man.
Africa.
La Niña results in wetter than normal conditions in southern Africa from December to February, and drier than normal conditions over equatorial East Africa over the same period.
Asia.
During La Niña years, the formation of tropical cyclones, along with a subtropical ridge position, shifts westward across the western Pacific Ocean, which increases the landfall threat to China. In March 2008, La Niña caused a drop in sea surface temperatures over Southeast Asia by 2 DEGC. It also caused heavy rains over Malaysia, the Philippines, and Indonesia.
South America.
During a time of La Niña, drought plagues the coastal regions of Peru and Chile. From December to February, northern Brazil is wetter than normal.
North America.
La Niña causes mostly the opposite effects of El Niño, above-average precipitation across the northern Midwest, the northern Rockies, northern California, and the Pacific Northwest southern and eastern regions. Meanwhile, precipitation in the southwestern and southeastern states is below average. This also allows way above-average hurricanes in the Atlantic and less in the Pacific. La Niñas occurred in 1904, 1908, 1910, 1916, 1924, 1928, 1938, 1950, 1955, 1964, 1970, 1973, 1975, 1983, 1988, 1995, 1998, 2007, 2010, and 2011. In Canada, La Niña will, in general, cause a cooler, snowier winter, such as the near record-breaking amounts of snow recorded in the La Niña winter of 2007-2008 in eastern Canada.
Transitional phases.
Transitional phases at the onset or departure of El Niño or La Niña can also be important factors on global weather by affecting teleconnections. Significant episodes, known as trans-Niño, are measured by the Trans-Niño Index, TNI. Examples of affected short-time climate in North America include precipitation in the northwest U.S. and intense tornado activity in the contiguous U.S. During strong El Niño episodes, a secondary peak in sea surface temperature across the far eastern equatorial Pacific Ocean sometimes follows the initial peak.
Recent occurrences.
A strong La Niña episode occurred during 1988 to 1989. La Niña also formed in 1983, in 1995 and from 1998 to 2000, with neutral periods from 2000 to 2002. In recent times, an occurrence of El Niño started in September 2006 and lasted until early 2007. From June 2007 on, data indicated a moderate La Niña event, which strengthened in early 2008 and weakened before the start of 2009. The 2007 to 2008 La Niña event was the strongest since the 1988 to 1989 event. The strength of the La Niña made the 2008 Atlantic hurricane season one of the most active since 1944. 16 named storms had winds of at least 39 miles per hour, 63 kilometers per hour, 8 of which became 74 miles per hour, 119 kilometers per hour, or greater hurricanes. According to NOAA, El Niño conditions were in place in the equatorial Pacific Ocean starting June 2009, peaking in January-February 2010. Positive SST anomalies, El Niño, lasted until May 2010. SST anomalies then transitioned into the negative, La Niña, and have now transitioned back to ENSO neutral during April 2012. In early July, NOAA stated that El Niño conditions have a 50+% chance of developing during the Northern Hemisphere summer. As the 2012 Northern Hemisphere summer started to draw to a close, NOAA stated that El Niño conditions were likely to develop in August or September. The September 30, 2013 NOAA report indicates high probability of no El Niño or La Niña, ENSO neutral, through spring 2014. However, an El Niño was expected to develop during the summer of 2014 and last for the rest of the year, with a probability of over 50%.
Remote influence on tropical Atlantic Ocean.
A study of climate records has shown that El Niño events in the equatorial Pacific are generally associated with a warm tropical North Atlantic in the following spring and summer. About half of El Niño events persist sufficiently into the spring months for the Western Hemisphere warm pool to become unusually large in summer. Occasionally, El Niño's effect on the Atlantic Walker circulation over South America strengthens the easterly trade winds in the western equatorial Atlantic region. As a result, an unusual cooling may occur in the eastern equatorial Atlantic in spring and summer following El Niño peaks in winter. Cases of El Niño-type events in both oceans simultaneously have been linked to severe famines related to the extended failure of monsoon rains.
ENSO and global warming.
During the last several decades, the number of El Niño events increased, and the number of La Niña events decreased, although observation of ENSO for much longer is needed to detect robust changes. The question is whether this is a random fluctuation or a normal instance of variation for that phenomenon or the result of global climate changes toward global warming. The studies of historical data show the recent El Niño variation is most likely linked to global warming. For example, one of the most recent results, even after subtracting the positive influence of decadal variation, is shown to be possibly present in the ENSO trend. The amplitude of the ENSO variability in the observed data still increases, by as much as 60% in the last 50 years. The exact changes happening to ENSO in the future is uncertain, different models make different predictions. It may be that the observed phenomenon of more frequent and stronger El Niño events occurs only in the initial phase of the global warming, and then, for example, after the lower layers of the ocean get warmer, as well, El Niño will become weaker than it was. It may also be that the stabilizing and destabilizing forces influencing the phenomenon will eventually compensate for each other. More research is needed to provide a better answer to that question. The ENSO is considered to be a potential tipping element in Earth's climate.
The Modoki or Central Pacific El Niño debate.
The traditional Niño, also called Eastern Pacific, EP, El Niño, involves temperature anomalies in the Eastern Pacific. However, in the last 2 decades, non-traditional El Niños were observed, in which the usual place of the temperature anomaly, Niño 1 and 2, is not affected, but an anomaly arises in the Central Pacific, Niño 3.4. The phenomenon is called Central Pacific, CP, El Niño, dateline El Niño, because the anomaly arises near the dateline, or El Niño Modoki. Modoki is Japanese for similar, but different. There are flavors of ENSO additional to EP and CP types, and some scientists argue that ENSO exists as a continuum, often with hybrid types. The effects of the CP El Niño are different from those of the traditional EP El Niño. For example, the new El Niño leads to more hurricanes more frequently making landfall in the Atlantic. The recent discovery of El Niño Modoki has some scientists believing it to be linked to global warming. However, comprehensive satellite data go back only to 1979. More research must be done to find a correlation and study past El Niño episodes. More generally, there is no scientific consensus on how if climate change may affect ENSO. There is also a scientific debate on the very existence of this new ENSO. Indeed, a number of studies dispute the reality of this statistical distinction or its increasing occurrence, or both, either arguing the reliable record is too short to detect such a distinction, finding no distinction or trend using other statistical approaches, or that other types should be distinguished, such as standard and extreme El Niños. Following the asymmetric nature of the warm and cold phases of ENSO, a study could not identify such distinctions for La Niña, both in observations and in the climate models. The first recorded El Niño that originated in the Central Pacific and moved toward the east was in 1986.
Health and social impacts of El Niño.
Extreme weather conditions related to the El Niño cycle correlate with changes in the incidence of epidemic diseases. For example, the El Niño cycle is associated with increased risks of some of the diseases transmitted by mosquitoes, such as malaria, dengue, and Rift Valley fever. Cycles of malaria in India, Venezuela, Brazil, and Colombia have now been linked to El Niño. Outbreaks of another mosquito-transmitted disease, Australian encephalitis, Murray Valley encephalitis, MVE, occur in temperate southeast Australia after heavy rainfall and flooding, which are associated with La Niña events. A severe outbreak of Rift Valley fever occurred after extreme rainfall in northeastern Kenya and southern Somalia during the 1997-98 El Niño. ENSO conditions have also been related to Kawasaki disease incidents in Japan and the west coast of the United States, via the linkage to tropospheric winds across the North Pacific Ocean. ENSO may be linked to civil conflicts. Scientists at the Earth Institute of Columbia University, having analyzed data from 1950 to 2004, suggest ENSO may have had a role in 21% of all civil conflicts since 1950, with the risk of annual civil conflict doubling from 3% to 6% in countries affected by ENSO during El Niño years relative to La Niña years.
Cultural history and prehistoric information.
ENSO conditions have occurred at 2 to 7 year intervals for at least the past 300 years, but most of them have been weak. Evidence is also strong for El Niño events during the early Holocene epoch 10,000 years ago. El Niño affected pre-Columbian Incas and may have led to the demise of the Moche and other pre-Columbian Peruvian cultures. A recent study suggests a strong El Niño effect between 1789 and 1793 caused poor crop yields in Europe, which in turn helped touch off the French Revolution. The extreme weather produced by El Niño in 1876-77 gave rise to the most deadly famines of the 19th century. The 1876 famine alone in northern China killed up to 13 million people. An early recorded mention of the term El Niño to refer to climate occurred in 1892, when Captain Camilo Carrillo told the Geographical Society Congress in Lima that Peruvian sailors named the warm north-flowing current El Niño, because it was most noticeable around Christmas. The phenomenon had long been of interest because of its effects on the guano industry and other enterprises that depend on biological productivity of the sea. Charles Todd, in 1893, suggested droughts in India and Australia tend to occur at the same time. Norman Lockyer noted the same in 1904. An El Niño connection with flooding was reported in 1895 by Peasett and Eguiguren. In 1924, Gilbert Walker, for whom the Walker circulation is named, coined the term Southern Oscillation. The major 1982-83 El Niño led to an upsurge of interest from the scientific community. The period 1990 to 1994 was unusual in that El Niños have rarely occurred in such rapid succession. An especially intense El Niño event in 1998 caused an estimated 16% of the world's reef systems to die. The event temporarily warmed air temperature by 1.5 DEGC, compared to the usual increase of 0.25 DEGC associated with El Niño events. Since then, mass coral bleaching has become common worldwide, with all regions having suffered severe bleaching. Major ENSO events were recorded in the years 1790-93, 1828, 1876-78, 1891, 1925-26, 1972-73, 1982-83, 1997-98 and 2009-2010. With 1997-1998 episode being one of the strongest ever.
Climate networks.
Analysis of El Niño events using climate networks showed the dynamics of the climate network is very sensitive to El Niño events. Many links in the network failed during El Niño events.